According to National Electrical Code Section 350.60 on, all raceways and cables that are run within 10 feet of a lightning protection system must be bonded to that system. If the liquid-tight flexible metal conduit, or LFMC, is running through a wall of a unit and is within 10 feet of the building's lightning protection system, then a bond bushing is required at the pecker head to bond the LFMC to the lightning protection system. As for reducing washers, the National Electrical Code does not specifically address them. However, reducing washers are considered an acceptable method for connecting LFMC to hubs and other enclosures, but firstly, reducing washers must be listed for use with LFMC. Secondly, the washers must be properly sized to fit the hub or enclosure. Thirdly, the threads on the reducing washers must be engaged a minimum of 5 full threads. National Electrical Code Section 350.60 is a correct section to reference for bonding requirements of conduits and raceways near lightning protection systems. Remember to always consult the latest edition of the National Electrical Code and local amendments for the most accurate and up-to-date information. When installing electrical systems, ensure that all components are properly listed and rated for the intended application. This includes connectors, conduits, and bonding devices. Incorrectly rated or installed components can create safety hazards and violate electrical codes. Always verify the listing and suitability of components with the manufacturer's specifications. Additionally, proper grounding and bonding are crucial for electrical safety. Grounding provides a path for fault current to return to the source, while bonding ensures that all metallic parts are at the same electrical potential. This minimizes the risk of electric shock and equipment damage. Follow the requirements outlined in the National Electrical Code Article 250 for grounding and bonding. When working with flexible metal conduits, ensure that they are properly supported and secured. This prevents strain on the conduit and its connections. Use appropriate conduit supports and straps to maintain the integrity of the raceway system. Additionally, avoid sharp bends in the conduit, as this can damage the conductors inside. Maintain a smooth and gradual bend radius to ensure proper wire pulling and prevent insulation damage. When using reducing washers, ensure that they are properly tightened and secured. Loose connections can create electrical resistance and heat, leading to potential fire hazards. Use appropriate tools and techniques to tighten the reducing washers to the manufacturer's recommended torque specifications. Periodically inspect electrical systems for signs of damage or deterioration. This includes checking for loose connections, corroded components, and damaged insulation. Address any issues promptly to prevent further damage and ensure the safety of the electrical system. Furthermore, consider the environmental conditions in which the electrical system is installed. In damp or corrosive environments, use appropriate corrosion-resistant materials and sealing techniques to protect the electrical components. This will extend the lifespan of the electrical system and prevent premature failure. When working with electrical systems, always energize the circuit before performing any work. Use appropriate lockout-tagout procedures to prevent accidental re-energization. Verify that the circuit is de-energized using a voltage tester before touching any conductors or components. When selecting conductors for electrical systems, ensure that they are properly sized for the intended load. Use appropriate ampacity tables and derating factors to determine the correct conductor size. Overloaded conductors can overheat and cause insulation damage, leading to potential fire hazards. Always refer to the National Electrical Code Chapter 3 for conductor sizing requirements. Additionally, consider the voltage drop in the electrical system. Excessive voltage drop can cause equipment malfunction and inefficiency. Use appropriate voltage drop calculations to determine the correct conductor size and minimize voltage drop. Always refer to the National Electrical Code Chapter 9 for voltage drop calculations. When installing electrical equipment, ensure that it is properly grounded and bonded. This includes connecting the equipment grounding conductor to the grounding electrode system. Additionally, bond all metallic parts of the equipment together to ensure that they are at the same electrical potential. This minimizes the risk of electric shock and equipment damage. Always refer to the National Electrical Code Article 250 for grounding and bonding requirements. When working with electrical panels, ensure that they are properly labeled and organized. This makes it easier to identify circuits and perform maintenance. Use appropriate circuit directories and labeling systems to clearly identify each circuit breaker or fuse. Additionally, keep the electrical panel clean and free of debris to prevent overheating and damage. Regularly inspect electrical panels for signs of corrosion, loose connections, and damaged components. Address any issues promptly to prevent further damage and ensure the safety of the electrical system. When performing electrical work, always follow the manufacturer's instructions and recommendations. This includes using the correct tools and techniques for installation and maintenance. Deviation from the manufacturer's instructions can void warranties and create safety hazards. Consult the manufacturer's documentation for specific guidance on the installation and maintenance of electrical equipment. Additionally, consider the ambient temperature in which the electrical system is installed. High ambient temperatures can reduce the ampacity of conductors and increase the risk of overheating. Use appropriate dirting factors to compensate for high ambient temperatures. Always refer to the National Electrical Code Table 310.15 for ampacity correction factors. When working with electrical systems in hazardous locations, use equipment that is specifically designed and rated for those environments. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Use explosion-proof equipment and wiring methods to prevent ignition of these substances. Always refer to the National Electrical Code Article 500 through 516 for hazardous location requirements. Furthermore, consider the presence of harmonics in the electrical system. Harmonics are distorted waveforms that can cause equipment malfunction and overheating. Use appropriate harmonic mitigation techniques, such as filters and reactors, to reduce the level of harmonics in the electrical system. Always refer to the Institute of Electrical and Electronics Engineers Standard 519 for harmonic control recommendations. When working with electrical systems in healthcare facilities, use equipment that is specifically designed and rated for those environments. Healthcare facilities have unique electrical requirements to ensure patient safety and prevent electrical shock hazards. Use isolated power systems and ground fault protection devices to minimize the risk of electrical shock. Always refer to the National Electrical Code Article 517 for healthcare facility requirements. Furthermore, consider the impact of electromagnetic interference, or EMI, on the electrical system. EMI can disrupt the operation of sensitive electronic equipment and cause data corruption. Use appropriate shielding and filtering techniques to minimize the effects of EMI. Always refer to the Institute of Electrical and Electronics Engineers Standard 1100 for power quality recommendations. When working with electrical systems in industrial facilities, use equipment that is specifically designed and rated for those environments. Industrial facilities have demanding electrical requirements due to heavy machinery and harsh operating conditions. Use heavy-duty equipment and wiring methods to withstand the rigors of industrial environments. Always refer to the National Electrical Code Article 670 for industrial machinery requirements. Additionally, consider the use of surge protection devices to protect electrical equipment from voltage surges. Voltage surges can damage sensitive electronic equipment and cause premature failure. Use surge protection devices at the service entrance and at individual equipment locations to minimize the risk of surge damage. Always refer to the National Electrical Code Article 280 for surge protection requirements. When working with electrical systems in data centers, use equipment that is specifically designed and rated for those environments. Data centers have critical power requirements to ensure uninterrupted operation of servers and networking equipment. Use uninterruptible power supplies, or UPSs, and backup generators to provide continuous power in the event of a power outage. Always refer to the Telecommunications Industry Association Standard 942 for data center infrastructure requirements. Furthermore, consider the use of energy-efficient lighting systems to reduce energy consumption and lower operating costs. Use light-emitting diode, or LED, lighting fixtures and controls to maximize energy savings. Always refer to the Illuminating Engineering Society Standard 90.1 for energy-efficient lighting recommendations. When working with electrical systems in commercial buildings, use equipment that is specifically designed and rated for those environments. Commercial buildings have diverse electrical requirements to accommodate various tenants and applications. Use flexible wiring systems and modular power distribution units to adapt to changing needs. Always refer to the National Electrical Code Article 705 for interconnected electric power production sources. Additionally, consider the use of renewable energy sources, such as solar photovoltaic or PV systems, to generate electricity and reduce reliance on fossil fuels. Use grid-tied inverters and energy storage systems to integrate renewable energy sources into the electrical system. Always refer to the National Electrical Code Article 690 for solar photovoltaic system requirements. When working with electrical systems in residential buildings, use equipment that is specifically designed and rated for those environments. Residential buildings have unique electrical requirements to ensure the safety of occupants and prevent electrical hazards. Use arc fault circuit interrupters, RFCs, and ground fault circuit interrupters, or GFCIs, to protect against electrical fires and shock hazards. Always refer to the National Electrical Code Article 210 for branch circuit requirements. Furthermore, consider the use of smart home technologies to enhance energy efficiency and improve the comfort and convenience of occupants. Use smart thermostats, lighting controls, and energy monitoring systems to optimize energy consumption. Always refer to the Consumer Technology Association Standard 2045 for smart home device interoperability. When working with electrical systems, always prioritize safety and follow all applicable codes and standards. Electrical work can be dangerous, and it is essential to take precautions to prevent accidents and injuries. Use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools to minimize the risk of electrical shock and burns. Additionally, always work with a qualified and licensed electrician to ensure that electrical work is performed safely and correctly. Remember to consult the latest edition of the National Electrical Code and local amendments for the most accurate and up-to-date information.